So now we're going to start with the graph and find the factors. So at each, whenever we factored, we found those x-intercepts. So we got to still mark those. So I like putting a little dot at each. And then start with the skeleton. So you have f of x is equal to, you're going to have 3 intercepts. How do we get our graph to go through -4?
Plus 4.
X plus 4. How do we get it to go through -2? And how do we get it to come back up through 1? Now, if you look at graph 2, it's almost the same thing, right? It's got the same x-intercepts. What's the only difference? It's flipped. How do we get our graph to flip? Negative. So we're looking at negative x plus 4, x plus 2, and x minus 1. What if it bounced, like it does on number 3? You square that term. So I'll let you do 3 and 4 on your own. Take a look at number 5. So we're going to start with our skeleton of the equation. How many parentheses are we going to have? Yep, 3 of them. Is it going to be positive or negative out front? Got to look at our end behavior. So we start up high and end down low. So we're going to need a negative. We're going down the mountain. And are any of them bouncing? So are any of them going to be squared? Nope. Okay, cross, cross, cross. So x plus 4, x plus 2, and x minus 7. And the last one on number 6. And I would put a little, mark all of the x-intercepts. And don't forget that x equals 6 over here. And then look at the end behavior. Is it going to be positive or negative? Positive. It's going up, up. How do we get it to bounce on -4? 4. Right. So x plus 4 squared gets that bounce. And we cross through -2, so x plus 2. Bounce at 3. X minus 3. And then go cross through 6.
Number 3.
So we've been finding zeros for a really long time now. Every time we solve for x, we're finding those zeros and where they cross the x axis at. So on example 4, we're looking at what's our zeros going to be. X equals -3, x equals, and x equals 1. Okay. So we can go ahead and start graphing those on the axis. So x equals -3, -2, and then now we know end behavior, so we can add that on to kind of complete our picture almost. So our end behavior, what's our degree of the function? We're not used to seeing it in this form, right? We're used to seeing it in standard form where we can just look at the biggest exponent and call that the degree. But when it's factored, it's a little easier for some. We just have to count how many x's there are. So it's the degree of our function. 3 is 3, which is odd. And what's our leading coefficient? Is it positive or negative? It's going to be positive. We could FOIL it all out and see what our, but it doesn't matter what the number is, as long as it's positive out front. So everyone with their hands, show me what the end behavior is going to be. We have an odd positive function. Everyone.
Your spaghetti arms. Odd positive. What's it going to be?
You guys seen that picture?
Nathan,
of like the
nope.
dance?
Odd positive.
So we're going up the mountain, just like a line. So straight down low, go up high. So you can go ahead and, if you want that to be your first step, draw those arrows on your graph. And you don't have to do this, but what's our y-intercept going to be? That's going to kind of give us a better picture of what the graph's going to be. How do we find our y-intercept on any graph, any function?
Plug in 0 for x.
Plug in 0 for x. So you even just type it into your calculator. That's how it looks. So I'm going to type in what's given, but instead of x, I'm going to put a 0. So 0 plus 3, 0 plus 2, and 0 minus 1. So our y-intercept is going to be -6. Again, you don't have to do that, but it kind of gives you a more accurate estimate. So, now 6. And then you just kind of go for the right. Start at the bottom, go through your x-intercepts, and end at the top. Alright, so what are our x-intercepts? When we solve this, x equals, don't forget the one out front. That's commonly missed. So when you set negative x equal to 0, x is equal to 0. X plus 3 gives us x plus 1 gives us 1, and x minus 2 gives us 2. So you can go ahead and put those on your graph. You have 0, -3, -1, and 2. What's the degree of our function? Yeah, 1, 2, 3, 4 x's. And is our leading coefficient positive or negative? Negative. We have that negative sign out front. So everyone point with their hands. What's our end behavior? Down, down. What's our y-intercept? 0. We didn't even have to plug it in because we already saw it crossed right there at x equals 0. Do any of them bounce? Nope. We're just going for our ride. Going through, cross, 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 and down. So now we're on the multiplicity. So the multiplicity is how many times that x-intercept happens. Oh my goodness. So this is already on your paper, but highlight it or circle it or underline it. So if the multiplicity is odd, so if the x-intercept happens once, or 3 times, or 5 times, or 17 times, it's going to cross through the axis. You kind of saw that on the first and third graph of your activity when we started out.
So they say like this, like x plus 3 to the third.
Yep. So that would just cross right through. When it's even is when it bounces. So when it's squared, or if it's to the 4th power, that's when it's going to bounce. So on this, we'll do this example together. For number 5, what's our x-intercept? So the first one gives us 2. What's the multiplicity of x equals 2? How many times does it happen? Just once. The middle term, x plus 3 squared, gives us x equals -3. And what's our multiplicity? How many times does it happen? Twice. So that one, I'm going to put a B there to remind myself that it's going to bounce when I grab it. Then our last term, x minus 4, gives us x equals 4 with multiplicity 1. What's our end behavior going to be? What's our degree? Our degree is 4. And is it positive or negative? Positive. So it's going to be an up, up. So I'll start out with that end behavior. Now I'm going to graph these x-intercepts. So x equals 2. X equals negative 3. And sometimes I even put a b right there, just again to remind myself it's going to bounce when I graph it. And then x equals 4. Everyone, use your calculator, find the y-intercept on their own. 72. So you can, I know it's not on our 10 by 10 graph, but you can just put a dot up there and say, okay, that's 72. Okay? So if we plug in zeros, you're left with negative 2 times 3 squared times negative 4. Did you forget to square it? Yeah. So that should give us 72. So now we have all our information on the graph. We just have to fill in our curve. So we're going to start up high, bounce, go all the way up to 72, cross at 2, cross at 4, and connect with their up arrow. So what's our first x-intercept? Means that negative x squared equal to 0. 0. And the multiplicity of 0 is 2. It's going to bounce. Our next x-intercept, Mariah. Our next x-intercept. Good. What's that multiplicity? How many times does it happen? Just once. Alex, what's our next x-intercept? 5 with multiplicity 1. You can go ahead and graph those. So it's going to bounce at 0. It's going to go through at negative 4. It's going to go through at 5. Ethan, what's our end behavior going to be? We have, what's our degree of our function? Yep, so our degree is 4. So we know it's going to be in the same direction. Is it positive or negative? Negative. So it's going to be up, up, or down, down? Down, down. And since we already have a y-intercept at 0, we don't need to find that. We can just go on the roller coaster ride. So we're really just looking for when it crosses, when it bounces, and when it crosses again. Make sure you have the end behavior right. So we're going to take everything from factoring and solving all the way to graphing. So put it all together. I'm going to have you guys try it since it's nothing new. It's just a lot of different steps. So first, you're going to get the end behavior. Then you're going to factor it so you can solve for zeros. It has 4 terms. How do we know how to solve a 4-term polynomial grouping? Okay. And then you can grab it. So try that. All right. So hopefully we could factor by grouping and get our x-intercepts. None of them are squared, so they all have multiplicity 1, which means there's no bouncing. Our degree is in standard form, so we look at our third degree, and it's positive, so it's going up the mountain, just like a line. And then when you plug in 0, all of this cancels, and you're left with negative 12 for your y-intercept.